CloudX Lab is actually a Bangalore-based startup company. So what they do, they have a cluster. They sell it to students to learn. Like if let's say I want to learn big data, I can pay some money and they will allow me to access this. So from anywhere you can connect. It's very easy, right? If you have a browser in Amazon, so I will just log on to AWS, Amazon Cloud. Okay, I just want to show you one small thing. Yeah, so this is basically the Amazon's homepage where you can see all the services are listed, right? And we are not interested in all the services, right? We are particularly interested in big data services. So Amazon has a service called EMR. So you can simply search for EMR here. So Amazon has a service called Elastic MapReduce. Well, the service has the least to do with MapReduce. They're just calling it as Elastic MapReduce. Okay, and this is particularly a very, very useful service these days. Many organizations, like I said, are using this service. What is this service? It will allow you to create a big data cluster on the cloud within 5 to 10 minutes. So if somebody want to create a cluster, then analyze some data and then delete the cluster thereafter, you can set it up. It's very easy to do. So all you need to do is that click on this create cluster. So what you need to do is that if you have landed in the EMR page, you can click on this create cluster. Okay. And by default, you will land in something called quick options. You can click on this advanced option, right? And you can see what tools you need to install in the cluster. See, Hadoop is by default picked. So you are getting Hadoop version 2.8.4. You will get. Do you want Jupyter? Do you want Hive? Yes, I picked Hive. Do you want Spark? Yes, probably I want Spark. Pick this. Zeppelin, Pace, HBase, probably I want HBase. Scoop, HCatalog, Pig, Zookeeper. So TensorFlow, see? So now TensorFlow is also there. So you want to do ML kind of stuff, right? You can just say. So as of now, I will say that I just want Hadoop, Hive, these tools, okay? And then you scroll down a bit and then you say next. And in the next page, you can ask how many machines you want in the cluster. So you see there is a master machine here, okay? And by default, you will get one master machine. That is default. And core machine. So Hadoop works in a master-slave architecture. There will be one master and many slave machines to do the job. So core machines are your slave machines. And how many slave machines you need? By default, it is selected 2. So that means I can change this to 90 or 100 depending on your account limit you will get. So I will say that I want one master instance and 2 slave instances. Okay. And what kind of a machine you want, you can select from here. So these are the hardware options you will get, right? And for example, if I select the first machine, I will get 2 CPU, 3.8 GB RAM. But here it is 4 CPU, 8 GB RAM, etc., etc. So probably we will stick with a smaller machine like 4 CPU and 8 GB RAM, something like this. Even for this, I will say this machine I want. I can just save it. So you can decide the configuration here and I can say next, again say next. I can say this and security groups and you can say starting, it just says starting and probably in another 5 minutes or something it will create a 3-node cluster and give it to me and all the tools will be installed, whichever I picked. Then I can simply upload the data and analyze the data. So this is the disposable cluster. There is a button called the terminate here. So once you are done with your activity, you terminate it. There is nothing else you can do.
No, pricing we have to check.
This is a free account, right? What do you mean?
Amazon actually gives you a 12-month free account.
Yes, 1 year.
Yeah, but that does not cover a lot of things.
Yeah, I mean, they're very limited to choose the
So the machines, so when you sign up with Amazon Web Services for the first time,
they will say that we will give you a 1 year free subscription. And that's nice. Except it is not. So in that it is a very limited usage. So they will allow you to create machines with let's say 1 GB RAM. If you want 2 GB RAM, you have to pay. So my machines are actually 8 GB RAM. we will charge for sure, right? So in the free tier or the 12 months free access, you will have only limited resources which you can use free. Otherwise, everything else will be chargeable actually, right? But that is just to test Amazon, you know. You cannot really run any production workload in that machines. So this will be chargeable. So how much charge you have to pay, you have to check before creating the cluster. How do you check?
Oh, that means I
So
create
when
and
you
kept
start-
it.
When you start, there is only one option, terminate. If you terminate, no charge.
So in Amazon, you have upfront purchase. You can say, I want to run this for 1 year. They will give you the total bill, let's say it is $1,000. They will give you a discount on that. They'll say pay 800 or 600, something lesser amount. But I do not think that is applicable for everything. So the more important point is, even though I created an EMR cluster, now there is one problem with my cluster. There is only one problem with my cluster. The cluster will come up, everything is nice, but who is managing my cluster? I don't have any administrative access in the cluster. That is bad. So this is not what people do. This is for occasions where you just want to create a cluster and do something. But if in your company, if somebody says that, okay, we need to create our own Hadoop cluster, then what you do is that you will bring up, let's say 10 machines individually. You will install Linux in them, then you will install Hadoop in them manually, you will set it. That is possible. And then you will have full control. You will install Spark, you will remove Spark. Here everything is Amazon is doing. You are just asking for a cluster. So that is not really what people do in production setup, right? This is for ad hoc cluster. We call it as ad hoc cluster. You get it when you want it, then you delete it. Right? But this is also popular. EMR is very popular these days. Even a person without Hadoop knowledge can create it. That is, at least that is what they say. Whatever data that you store, they don't have any access to the data. But another point is, if you are doing EMR and all, your data must be in Amazon cloud. Otherwise, it doesn't make any sense. Let's say all my data is in my laptop. Let's say 1 terabyte data. I have to first upload it, right? So that doesn't make any sense. So this is good for customers whose product is already in Amazon. And many customers are there like Flipkart. Entire Flipkart is in Amazon. So for them it is easy. Everything is in Amazon. They add a service. Yeah. So it says cluster ready after last step completed. So now we have the full-fledged cluster, right? You can connect with the cluster, do the analysis, everything that you want. You have 3 machines in the cluster and they are running, right? And we can do all the analysis that we want. If I go to the cluster, right, it's already done, but what I can do, I can say I want one more cluster. I go to clusters and I say create cluster. And this is the place where we were doing, right? So I will just say next. And if I scroll down, very interestingly, I did not show you this because, I mean, if I scroll here, can you see this? Auto scaling, not enabled. So by default, this feature called auto scaling is not enabled, which means it will not work. But I can simply say I want to enable it. If I enable it, it will ask me, when do you want to add one machine? When do you want to remove one machine? That's the rule. One machine or more than one machine. So here by default, it says when yarn memory is less than, so there is something called yarn memory, or I can add any rule. I can say that if the CPU, if the total CPU of 2 machines are more than 90%, then add one machine. Same concept here we are using, but here the only difference is that when you enable the rule, it is depending on the Hadoop resource utilization. That is why this yarn and all are coming. So you say if more programs are running or something, or my analytics is taking too long, let's say my query is taking 1 hour, add one more machine or remove one more machine. The beauty is that you can scale out and scale back. So when the load is less, they will automatically delete the machines. This you cannot do on premise. So I do not enable this because when I just created a cluster, but this is possible. Auto scaling is possible on EMR by default. What we do is that, let's say this is the Hadoop cluster. One of the very common problems in every Hadoop cluster is resource management. Meaning, let's say you are running with 100 machines in the cluster. 100 machines means each machine will have some RAM. Imagine 4 GB RAM. So total RAM will be what? You have 400 GB RAM, correct? And CPU is also there. Let's say one processor. Simple example. So you will have 100 processor core, right? Now, so these are some of the things which can help you even in machine learning or anywhere you go, because this is a concept which nobody understands, but probably the most important concept when you start working, which is called resource management. Whenever you write any program, be it machine learning or normal learning, whatever you write, if it needs to be executed, it needs resources, right? So imagine this is a cluster. You are a developer. You wrote a program. Okay, you wrote a SQL query. This SQL query is analyzing 1 terabyte of data. So if the SQL query want to run, it requires some RAM, some CPU from the cluster. Who will give this? How this will give? So on and so forth, right? So by default in Hadoop, there is a component called yarn. I did not talk about this, but there is a component called yarn in Hadoop. It's an integral part. Yarn is the resource manager. So yarn will decide resource management normally. So in a very normal cluster where there are not many programs running, you don't have to bother. If you submit a query or a program, yarn will allocate the resources to run. But in very hefty clusters, like in this 24/7 and all, they have only 60 nodes and lot of developers are there. So what will happen if everybody starts submitting programs? Your cluster capacity will become full. So then what will happen? Then the cluster is full. Then if one guy again submit a program, by default what will happen? His program will wait in a queue. The program will not be cancelled. It will wait in a queue. Okay, and then some program finishes and the resource becomes available. His program will start running. In order to manage this, you can do something called scheduling. Okay, so we do this all the time. So we will split the cluster into 3 queues. Okay, we will say there is Q1, Q2, Q3. So this is Q1, 2, 3. This is all the developers. This is all the testers. This is all the R&D team. And developers, we will say they will get 60% of the resources. Testing team get 20% and R&D get 20. So if you are a developer, when you submit your query, automatically the query will go to the developer queue, which has 60% of the cluster resource, right? Or if you are a tester, you get only 20%. So that way you have to control, and that is very important when in production, because writing a program may not be the big deal in production setup. Running it is very big deal, actually. And there are many programs which are not very critical. So if you have non-critical programs, you will schedule. This is a way to manage the total resources among multiple users. User management, basically, right? Considering on-premise cluster, right? And then there are rules who can take which queue, how much resource you can take. Otherwise, everybody starts submitting their program. And you can also have priorities. So one of your customer want a report every day 10 o'clock. Now to generate that report, your BI tool has to connect with Hive. So your Tableau, right? Tableau has a Hive connector. Tableau can connect with Hive. So if you have a table in Hive, Tableau can fire a query and visualize the data. So your customer is saying that I need a Tableau report every day 10 o'clock. So Tableau has to connect with Hive and fire a query. So at 10 o'clock, if your cluster is busy, what will happen? Your customer will not get the report. SLA will be broken, right? So that time you can have priority. For this customer, this query, it will run. Other jobs can wait. So resource management is a great headache. I have worked as a Hadoop admin for an year and a half. Not because of my passion, because of the circumstances, because the existing admin quit and there was nobody else, so I became the admin. I had no clue what is the role of an admin. Everybody will start complaining. Because I ran a query, the result is not coming. Because another customer is creating problem. There is only one cluster, right? So resource management is the biggest headache in a Hadoop cluster. Everything else can run. And especially when you are running Spark programs and all. Spark is very memory intensive. The moment you run this, it will grab RAM like anything. So other programs will have to release it. They have to wait, right? And you cannot kill this program also because somebody might be doing some analytics, right? So then you need to figure out a way in which, so that is where we are using this OZ. Uzi is like your cron. In Linux, you have cron job, right? So what typically administrators will do, so developers will come and say that I want to run this job, this program. So they will ask, is it critical? No. More than 25/7. If I get 1 more hour, I'll schedule there also. It will be totally busy. Because another problem is that people don't want to invest a lot of money. You go to your management, and say that I want to add 10 more machines to the cluster. Why? What is the problem now? Where is your total cost of investment has gone? There's 100 questions you will get. So he will say, what is the problem with the existing cluster? That is why I'm paying you. You are the admin, right? So then, but your developer are not, they are restless. They are saying that my programs are slow. So that is when you are figuring out each and every slot and the program is running or not. You have to make sure. But again, it is customer centric. Okay. So if the customers are very strong, they will say that we are ready to pay money and all. You can, if it is your own projects and all, you don't really bother. Like Bank of America and all, they are ready to invest any amount, doesn't care. They want the results fast, right? So there you don't have any other choice. They will say that we are not ready to wait. Whatever you do, we need the results fast. That's all. But some customers are like, so some of your managers will be like, why are you expanding the cluster? From where all these users came now? What queries are you running? This, that, etc.
So is there a way in which we can analyze the performance of different programs in a cluster? Like, for example, if I have a program which is running on the cluster, will I be able to find out whether it's slow because it's in a queued state, or because it is taking up a lot of resources, or because my program itself is coded very badly?
No, so there are multiple things. One is that certain programs, when you run in the cluster, you can choose resources for the program. Certain programs you cannot. So certain programs you have to fine tune before you run the program in a cluster. For example, if you are running a Hive query, Hive is a SQL query. So first you have to make sure your query is tuned. And then, I don't know if you're coming from database background, not sure. Yeah, so if you're running a Hive query, there is column-based statistics, there is table-based statistics, there is indexing, and there is partitioning. So these all things you will do. You make sure all this is working. And internally, Hive uses something called CBO, cost-based optimizer. The CBO works on all these parameters. And then you tell CBO, I have done all this, optimize my query. And then it is not, so your query part is done. I mean, your query is maximum optimized. You can never have an error in the query then. Then while running that, if you're getting the resource or not, that you have a UI for this yarn. This yarn has a UI where you can see all the programs running and how much time it took. And once the program completes, you get the complete log file where you can say what happened in the program. So running state is fine. If the program crashes or did not work, if a query gets aborted, then you need to look at the log and see why it went down. On the other hand, if you go for Spark and all, you have to ask for resources. Meaning, if I write a Spark program, if I run, okay, I have to go to Yarn and ask Yarn specifically give me this much amount of RAM, these many processor cores, depending on the data I'm having. So there the developer has a responsibility because he is writing how much resource he wants. So if you screw up your program and instead of asking for 10 GB RAM, you simply ask 20 GB. You will get 20 GB, but you're actually using only 10 GB. So that is your headache, right? So you have to figure out. So that is always a classic fight between developer and admin. So he could have written something and admin could have thought about something. But you have to troubleshoot it at different levels. And typically in every big data project, there will be somebody called a big data architect. There is a role called big data architect. That will be like a big shot in the company. He never speaks to anybody. He's like the god, right? So that's called a big data architect. Okay. So the big data architect is the guy who knows everything about the cluster. So anything that you run has to be passed by him. He has to vet it, say that it will run, then only it will run. So he is the guy who decides. He knows, right? He knows the admin side and developer side, and he will ask why you wrote it, why didn't you optimize it, or he knows in and out of what you have written. So everything has to be usually, I mean, again, company to company, it can all vary. Some companies allow independently you write your own program. They may not have money to hire an architect at all, right? So they will say you run it. But in typical client-facing projects, we have an architect. And everything that you write has to be vet by him. And some projects actually use these 3 stages: dev, test, production. Dev test, typical dev test production is there. Some projects do not use it. 2 types of there. So if you have dev test prod, it is much more easy because it is running through all 3 phases. You are almost certain that it is going to work, right? So many aspects are there when you work in that project, right? I have actually worked with many architects actually. I mean, in my due course, many architects have worked. So they're, I mean, I'm just joking, they're like really knowledgeable people. They know in and out of the entire system, right? Because if you design something like this, if one fine day nothing is working, you should at least know what to look into, right? Otherwise, how do you know what is not working? So they will know which component has failed, how it has failed, etc., right? So admin will be there, architect also will be there. Usually, you will have an architect who will design the workflows and all.